Our existence here on Earth, everything we know and understand, all the technology, relationships and memories, our entire reality, all came from a tiny speck, smaller than an atom. That speck was born with the Big Bang, and then began one of the craziest journeys through space and time. Today we're going to look at the history of the universe, a very high-level overview of how we got here. And by here, I mean here. Get ready. In less than 2 minutes, the universe began in a state of infinite density and temperature. It started out smaller than zero, and within less than a trillionth of a second, expanded faster than the speed of light. As the universe expanded, it cooled. Gravity separated from the other fundamental forces, electromagnetism, and the nuclear forces. Also, during this time, hydrogen and helium nuclei formed in a process called Big Bang nucleosynthesis. But no atoms could form because the universe was still too hot. This period is called the Planck epoch, and it lasted for less than 10 to the negative 43rd power of a second. Within seconds, the universe continued to expand and cool, allowing the formation of atomic nuclei and the beginning of the era of the formation of light elements. Within minutes, protons and neutrons combined to form atomic nuclei. After about 380,000 years, the universe had cooled enough for electrons to be bound to nuclei to form atoms. This is when the era of neutral atoms began, and it lasted for several 100,000 years. The universe went from being opaque to transparent, and electromagnetic radiation, or light, could travel freely through space for the first time. This allowed for the universe to start becoming more three-dimensional, because before photons would just bounce off of particles and not really go anywhere. But now they could travel freely. This allowed for the formation of large structures like stars and galaxies. Before this, most of the matter in the universe was spread out and only able to interact with each other close up. But once light could travel, this allowed for gravity to take hold and matter to clump together. After about 380,000 years, the universe was filled with mostly hydrogen and helium. This is also when the CMB was released, and it's still around today, and can be observed by modern telescopes. The CMB is basically the oldest light in the universe. The era of neutral atoms ended about 100 million years after the Big Bang when the first stars formed. We call these stars population 3 stars, and they were massive. They formed out of giant clouds of hydrogen and helium. These stars lived fast and died young. They went supernova and spread their guts across the galaxy. Their guts were elements like carbon, oxygen, neon, magnesium, and silicon. This material then became part of the next generation of stars. These stars were like our sun and are called population to stars. These stars are still around today, but are pretty rare. Most of the stars in the night sky are called population I stars, and they like our sun and have a lot of heavy elements in them. These elements help form things like rocks and ice. And most importantly for us, they allow for life to form now. While all this is happening, the universe is expanding, but there isn't anything pushing against anything, so there isn't any friction. So why would the expansion slow down? It wouldn't. This is called the theory of the heat death of the universe. At this point, all the energy in the universe will be evenly distributed, and the most efficient use of energy will be achieved. This means no more stars, no more galaxies, no more solar systems, no more planets, and definitely no more life. In short, a pretty boring existence. If you think this is depressing, don't worry, there are 2 other theories. One is called the Big Rip, and the other is called the heat death. With the Big Rip, the expansion of the universe would increase faster and faster until eventually the universe would rip apart and each galaxy would go its separate way and fly away into oblivion. With the heat death, the expansion of the universe slows down to the speed of light, because nothing can travel faster than light. This would mean that no galaxies could ever merge again, and everything would slowly drift apart into the darkness forever. To me, I think the heat death is the best case scenario, but it's all just speculation. Maybe the universe has a big recycling bin where it just goes into oblivion and then comes back out and starts the whole thing again. Who knows? But let's keep going. For now. About 1 billion years after the Big Bang, the universe was just starting to get interesting. Galaxies were starting to form and stars were getting big and heavy. It was right about now that the supernovas started kicking into high gear and started spreading heavy elements all throughout the universe. The reason I say heavy elements is because the big stars can only make so much. When you get to iron, it takes more energy to make it than you get out. So iron is kind of like the end of the road for stars. So iron is the heaviest element that stars can create. Iron is important for us because it's a key ingredient in things like blood. But the important thing to remember about supernovas is that they reblasting the surrounding area full of nutrients. This material is what makes planets, moons, asteroids, comets, etc. Some of this material made its way to Earth and is what ultimately made life possible. About 4.6 billion years ago, our sun formed from a cloud of gas and dust. Our Earth formed a little over 100 million years later. During this time, the Earth was very hot and molten. Over millions of years, the Earth started to cool. A solid crust formed and water vapor from the atmosphere condensed and fell to the surface as rain. Oceans formed, and it was around this time that life began. Life started out simple. It was single-celled organisms floating around in the ocean. These organisms are called prokaryotes. Life remained simple for quite some time. Then about 600 million years ago, multicellular life appeared. It wasn't until about 540 million years ago that life started to diversify rapidly. Now, this is called the Cambrian explosion. It wasn't really an explosion. It was more of a rapid diversification of life. Scientists aren't exactly sure why this happened, but it is thought that maybe oxygen levels increased, and this allowed for animals to get bigger and live more active lifestyles. Whatever the reason, this led to all the complex life we see around us today. Dinosaurs dominated the Mesozoic era. They ruled the Earth for over 165 million years. 66 million years ago, the dinosaurs died out. This opened the door for mammals to evolve. Mammals first appeared about 225 million years ago, but they were small and nobody really noticed them. But now they had a chance. Over the next 65 million years, mammals diversified and spread out. Some of them flew, so others walked on two legs. Some became gigantic and others became tiny. Birds are thought to have evolved from dinosaurs, or technically dinosaurs. It's about 66 million years ago. Mammals diversified even more, and many went extinct. The Holocene epoch began 11,700 years ago. This is the current epoch, and it's defined by the last ice age. Humans evolved in Africa about 2 million years ago. The Homo genus first appeared 2.8 million years ago. Homo sapiens, or modern humans, appeared about 300,000 years ago. Humans are pretty special. We developed tools, language, agriculture, and eventually built civilizations. We invented writing, math, computers, and space programs. We landed on the moon and sent probes to other planets in the solar system. Today we have satellites orbiting the Earth taking pictures of our home planet from space. We also have rovers exploring other planets and searching for signs of past life. We've come a long way since we were those simple bacteria in the ocean. The last few hundred years have been incredible. We discovered the structure of DNA. We put people into space and took them to the moon. We learned that the universe is expanding. We discovered the cosmic microwave background radiation and used it to map the entire sky. We found evidence of dark matter and dark energy. There's a lot more we don't know than what we do know. But thanks to technology, we're learning more every day. Maybe someday we'll find out what the universe is made of. Maybe someday we'll find intelligent life out there. Maybe someday we'll find out where we came from. All of this is possible. But for now, we can sit back and enjoy the fact that we are alive and on this amazing planet at this incredible time in history. So there you have it, a brief history of the universe. We've come a long way, and who knows what the future holds. Will we continue to explore and learn more about the universe, or will we destroy ourselves? Only time will tell. Thanks for watching. If you liked this video, please give it a thumbs up and share it with your friends. Also, don't forget to subscribe if you haven't already. Thanks again for watching, and I'll see you next time.